Hi guys, new unit. So we're going to jump into our new notes. Okay, first part here, learning target number 1. So just a reminder about how if we were to draw a free body diagram for this object, we'd say here's the circle and then we have force 1 as well as force 2. The other way I've seen this done is then stacked on top of each other. Okay. Now this works well when everything's linear. This works well when we're dealing with angles. Now this learning target 1 is all review. We went over this vectors and adding vectors and all that before, so this should be review. First, this idea that a vector has both magnitude and direction, and the length of the arrow represents the magnitude, and then the degrees represent the direction of that component. Okay. Okay, so we're going to add two vectors together. And so let's review that. If we have, just call it vector A, and we're going to add vector B, the way that we add a vector is we take the tail of the new vector and put it on the tip of the first. And then our resultant is from the tail of the first to the tip of the last, or the second, like that's our resultant. Okay. Now it doesn't have to be two vectors, we can have multiples, like we could have vector A, vector B, then we could also have like a vector C. And we can add all these together. We can take A, add it to B, and then add that to C. And then our resultant is from the tail of the first to the tip of the last. So our resultant, it's kind of hard to see, but it's right there. It's from the tail of the first to the tip of the last. Okay? Now, there's often we're dealing with two vectors, which we can then look at the triangle to see our resultant. Here's B added to A, and then our resultant is from the tail of the first to the tip of the second. Okay. Now, when we're dealing with a right triangle, then we can use Pythagorean theorem. But it's not always a right triangle that we're dealing with. Sometimes that angle is less than or greater than 90 degrees, and when that's the case, then we're going to use the law of cosines. This resultant is a squared plus b squared in addition to, or subtract, 2ab cosine theta. Okay. I want to solve for r, not just r squared. R would equal the square root of all that. A squared plus b squared minus 2ab cosine theta. Okay, we're going to use these on the next few practice problems. Okay, number 1. Find the magnitude of the sum of two vectors. One is 15 kilometers displacement and the other is 25 kilometer displacement. First, when the angle between them is 90 degrees, and then again when it's 135 degrees. Okay, let's start with the 90 degrees. So we have 15, and it doesn't specify which direction they're in, so we can make that call. We can choose that. So I'm going to say there's the direction of my 15 kilometers. Okay, and then please be careful with scale. If I've said that that's 15 kilometers and then we're dealing with 25, here's 25 kilometers. Okay, we have our right angle, and our resultant would be from the tip, or the tail of the first to the tip of the second. There's my resultant. Now let's use Pythagorean theorem. A squared plus b squared equals c squared, or r is equal to the square root of 15 kilometers squared plus 25 kilometers squared. Okay. Now, when I plug that in my calculator, I'm going to take the square root of 15 squared plus 25 squared (29.15). We're dealing with two sig figs, so let's keep in that range. 29 kilometers. Okay, that's R. Now, that's when they're 90 degrees. Let's look at when it's 135. So we can keep the 15 the same. Okay, but now instead of 90, here's 180, right? And so somewhere in this range-ish. Okay, there's my 25 kilometers, and the angle between them is 135. Okay, and here's the resultant. Okay, now it's not a right angle this time, so we need to use the law of cosines. Okay, so that is R is equal to the square root of a squared plus b squared minus 2ab cosine theta. We'll just say that 15 is our A and 25 is our B. Okay, so that would be 15 kilometers squared plus 25 kilometers squared minus 2 times by 15 kilometers multiplied by 25 kilometers cosine 135. Okay, so I have the square root of 15 squared plus 25 squared minus 2 times by 15 times by 25 times by the cosine of 135. Now it's important that oh, we didn't end. I need one more right there. That we make sure that our calculator is in degrees and not radians. Okay, so we have R is equal to 37 kilometers. Okay, so there's practice problem number 1. Let's see, where are we at on time? Yes, okay. So now let's look at example number 2. A car is driven 125 kilometers due west and then 65 kilometers due south. What is the magnitude of the car's displacement? Okay, if this is my coordinate system and I'm starting right in the middle, the car drives 125 kilometers west, okay, and then 65 kilometers south. Now this is kind of small, I'm going to make it bigger, but I just want to show that we're dealing with a right angle here. So we have 125 kilometers west, and then about half of that, 65 kilometers south. And our resultant is right there. Okay, so we have a right angle that we're dealing with. And so similar to here, let's use Pythagorean theorem. Okay, we have a squared plus b squared equals c squared, or R is equal to that square root of a squared, or 65 kilometers squared, plus b squared, 125 kilometers squared. So we have the square root, 65 squared plus 125 squared. So 3 sig figs, 141 kilometers. Okay, that's the magnitude of the car's displacement. Okay. Problem number 3. Find the magnitude of the sum of two forces, one 20 newtons, the other 7 newtons, when the angle between them is 30 degrees. Okay, so again, it doesn't tell us the direction, and so we can choose that. We can say that this 20 newtons is going to be that direction. We do know that the angle between them is 30, so this would be like 45, so we're going a little bit less than 45. So 30 degrees, this was 7.0. Okay, we'll find the magnitude of the sum. Well, the sum is from the tail of the first to the tip of the second. So that's actually my resultant there. And so this is not a right angle, so we need to use law of cosines. So r is going to equal the square root of a squared plus b squared minus 2ab cosine theta. Okay, we'll say a's are 20, so 20 newtons squared plus 7 newtons squared minus 2 times by 20 newtons multiplied by 7 newtons cosine of 30 degrees. Okay. The square root of 20 newtons squared plus 7 newtons squared minus 2 times by 20 times by 7 times by the cosine of 30 . Oh, it's right there. That's the problem. Okay, so we have 2 sig figs there. We're not really following sig figs like perfectly with our adding and subtracting and all that. We're just kind of doing in general when I look at this and I see the 2 sig figs. So I'm going to have my final answer be 2 sig figs as well. Okay. All right. Awesome. And let's see, where are we at time-wise? Okay, so on the next video, we're going to look at the trig side of this, and then we're going to look at some practice problems for adding vectors together like we did before. Okay, we did that, I think it was just last unit. Okay, so watch the next video for the second part of the lecture.